The whole point of everything we've been working towards, like stuff like this, where you have sine inverse of root 3 over 2. What angle has a sine of root 3 over 2? What angle has a tangent of -1? Things like that. Being able to do that is going to allow us, like we have shown you earlier, to start to solve the actual equations themselves. And what we're going to do is jump to 14.4, which is the solving of the equations. Now, what I'm going to do with this stuff now is, usually I've done graphing first, but I've decided to go into the equations because we just got done using all these inverse functions. I'm going to use the inverse functions via solving of the equations. We'll do that, then we're going to do the properties of trig, where it's simplify, verify, which is kind of like trigonometric proof. And then after that, we'll do another quiz over all that. And then we'll go right into the graphing. And graphing will take us to spring break. We'll graph all the regulars, shifted, as well as the reciprocal property trig functions. It seems like it's a lot when you start to do the graph stuff, but it's just a matter of adding fractions and then working through there. I've got some very nice shortcuts that allow us to do graphing pretty easy. But again, it stems from knowing how to set up something like this. For example, then, we don't need this. For example, if we said, we did this one earlier, we'll do this one, 2 sine of x plus 1 is 0. And I want to solve for x. And what we're going to do, so loud in the matches. What I'm going to do is I'm going to set this up to be what we're going to call within one revolution. Yes, ma'am?
If we're going to the ice cream social, do we just go down?
I think they're going to call a video, but you'll have to come back and watch the notes and then pull the homework up off the website and all that. It'll be on the video.
You're going to call a video?
They'll watch the video. I mean, they'll call it down. So there's 2 different ways of solving these. We're going to do what's called general solution. And then we're going to do within one revolution. X, theta, whatever. Today I'm going to talk about what I think is the easier of the 2, within one revolution. A little less stuff to worry about. Next week we'll get into the general solutions, as the general ones, as well as the problems we have to do some factoring with. So if you had to solve for x, think of it as 2x plus 1 is 0. What do you do first? Yes, sir?
Question about the within one revolution. Is that supposed to be greater than or equal to?
Theta is greater than or equal to 0, but less than or equal to 2 pi.
Okay.
There's no.
I know.
So it's not.
Because once it gets to 2 pi, then it becomes 0 again.
Yeah, you said
Well,
less than or equal to.
Theta is greater than or equal to 0, but less than 2 pi.
Okay.
Did I say less than equal to?
Yeah.
Sorry. Same thing. So here, do you guys, everybody agree I'd subtract 1, divide by 2?
Yeah.
So you get the sine of x. What angle has the sine of -1/2? Now you're looking at this between one revolution now. Between 0 to 2 pi, so you don't, I mean, I know that you guys want to drop down to for your negative value, but in this case, that negative value, if you say negative pi over 3 or whatever it is, it doesn't fall into my parameters, does it? No. So what you have to do is start to think about, well, what triangle gives me the half? 30, 60, 90. So 30, 60, 90 gives me the half. And lo and behold, it's the 60-degree angle. Okay. I'm sorry, the 30-degree angle. Excuse me. I did this with cosine earlier. So I know that the x value is going to be a 60-degree reference angle, but I have to figure out what quadrant is sine negative. Darn it! It's in the which ones? Where's sine negative?
In the fourth.
Fourth and
Third.
third.
Oh, yeah.
So this is going to give me my reference angles for the two spots that gives me the sine values. So my two angles are going to be at, well, my reference angle is 30 degrees, so it's going to be at a pi over 6. Pi over 6 down from 2 pi is 11 pi over 6. Pi over 6 down from pi is 7 pi over 6. 330. Oops. And 210. Yeah.
You did down from 2 pi?
Yes, sir. Sine's negative in those two because I'm looking at that parameter within one revolution, as opposed to dropping to the just find the sine value.
So then there would be 2
Yes, sir.
in the reference.
Yeah.
So there's 2 answers.
It's 2 answers. Yeah.
So what is the goal?
Solve for x. And you guys have been solving for x forever. This is just a trig way of solving for x. Each time you guys had to solve an equation, you started with 2 plus square equals 5. Then you turned it into 2 plus x equals 8. And then it was 3x plus 4 equals 17, and so on and so forth.
So does the thing that sine can only be quadrant 1 or 4 not apply?
That's when, yes, because you're throwing it to the revolution.
This is general.
Revolution.
So it's like negative 3 plus each side.
Using reference. Oh, just did this. Let's try this. 4 cosine of x plus 1 is negative 1. Remember, they replace these things all the time with x, theta, u, whatever. Potato.
That's petty, man.
Oh, this
Just
is.
kidding.
What?
So again, you're at a two-step equation. Shh, guys, you're at a two-step equation. What do you do first?
Subtract the 1.
Subtract 1. Divide by the 4. Exactly. So then I go back to the idea of what angle has the cosine of negative 1/2? 60. It's got to be my 60. Where then is cosine negative?
Wait, third and second.
Third and second. Cosine's negative in the third and the third and second quadrant. So if I'm coming up, my reference angle is 60 degrees. Coming up, that means that's 120. Coming up, pi over 3, so it is. Moving down pi over 3 makes it 4 pi over 3. And 60 degrees more than 180 is? No, it's 206.
Whoa! Shoot. Math is broken.
Get it?
240? No, it's 207 now.
You use that one like yesterday.
Oh my god.
Root 3 tangent of x minus 1. Obviously, add 1, divide by root 3. Okay. So x is going to be what angle has 1 over root 3. Or root 3 over 3. But do I need to rationalize? No. And this is an example of why I don't need to rationalize. The reason I don't have to, Shuki, is because what's the point? Because if I rationalize it, I get root 3 over 3, and I still got to figure out what triangle it is. I know that this is my opposite, that's my adjacent, so my opposite and my adjacent, I'm done, 30 degrees. Instead of, I mean, you can, there's nothing wrong with it, it just makes it easier by not. There are times, I mean, because you don't need it as a solution to solve the problem, okay? So knowing that you have a reference angle of 30 degrees, Tangent's positive where and where? First and third. So here's 30, here's down 30. So this is pi over 6, and the other one would be? Don't lean your chickens. 7 pi over 6. So you're at 30 degrees, pi over 6, 210, and pi over 6. Or 7 pi over 6, excuse me.
7 pi noticed me. You really don't get that joke, do you?
No, I don't try not to listen to you, so it's okay.
That's wrong. In any other situation, I always say I was disrespectful. That was sleep
Remember, what we're doing here is just trying to find how the angles within one revolution. We're not trying to set up what are called general solutions or anything like that. We'll get into that next week. It's a little bit more complicated, but it's still the same premise. I'm not going to do factoring yet, so let me do this one. Oh, where is it?
What? Did you actually like?
4 cosine squared of x minus 3 is 0.
It's a like this swim fins and everything. It's super swim like these super.
It's an inverse cosine. There's a reciprocal cosine at the root. Again, 4 times the cosine squared of x minus 3 equals 0. I'm going to solve for x. I'm still going to do the exact same thing as if it was 4x squared minus 3 equals 0. I still add 3, I still divide by 4, and then I have to take a square root. So here's what happens. You get cosine squared equals 3/4. How do you undo squaring? Square root. What happens when you square root over an equal sign?
Oh no.
And I get plus minus root 3 over 2. Which means, how many angles am I going to wind up with in one row? Good.
Oh my gosh. Why are you doing this to us? That's not okay.
Because cosine is positive in 2 spots and it's negative in 2 other spots. There are 4 different angles. There are 4 angles that have a reference angle that gives me root 3 over 2. Yes, ma'am.
Okay, with the x and the square, what is x?
That's the terminology. When you have it like this, that's how they write it. They write it as cosine squared x. It means the same thing as cosine.
So you don't equal to root of x then?
No,
Oh.
that's how you undo it. Cosine squared of x means cosine x times cosine x. That's what that means. So now, what angle gives you the root 3 over 2?
30.
Oh, that's right. I have to plug my calculator.
So that means you have 4 angles then with a reference angle of 30 degrees. Pi over 6. So you have up 30, so you're 30, 150, down 30, down 30, 210, and 330. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Each one of those angles has a reference angle of 30 degrees, and each one of them, if I took the cosine of it, it's going to give me either positive or negative root 3 over 2. That's what that means.
I like it.
Just quote.
I get how you get the ones in 1, 2, and 4.
Uh-huh.
I don't get why you get the fourth one and the
The
third
third-
one.
When you move into the third quadrant, you're coming off of 180 degrees, so you're adding.
I know, but like before we only had 2 because it was negative 1, 5. But I thought like cosine didn't go there. I don't know.
You're thinking just, these are set up to be x is between 0 and 2 pi. I'm solving for all possible angles that give me that value within that revolution, as opposed to find that within the specific parameter. Okay? It's a little bit different.
So you just kind of have to, after you get the reference angle, you have to
Yep.
use your head and just kind of think of it.
Yes, sir.
Wait, so you do it in all 4 quadrants because it's plus minus?
Yep. Yep. Exactly. Oh, I just did that one. Never mind. Cosecant of x minus 2 is 0. Try. What do you do first? Add 2. What angle has a cosecant value of 2? 30. So at pi over 6, your cosecant is 2. What other quadrant is cosecant positive 2? Second. Let me show you what happens when we talk about general. If I talk about general solution, it basically means how long does it take you to get back to where you start. So if I start at pi over 6, how long does it take me to get to here? And then is that the same amount to get all the way back to here? No. So I go back to this. Starting from here, how long does it take me to get to there? I don't know what this 360 is. 2 pi. So it would be 2 pi over 6 plus 2 pi n, I think, for number of revolutions. Yes, ma'am?
I'm pretty sure the thing started at like 210.
Weren't they making announcements?
No, that was for track.
We were supposed to.
Pretty sure.
That's honest.
You always thought.
I'm worried about math right now. Please proceed.
And then again, you start here. How long does it take to get back around? 2 pi. That's what general solution is going to look like, except when you start getting into the weird ones. When you have a tangent value, that's positive. When tangent's positive, it's directly across from one another in quadrants 1 and 3. It's just plus pi. So let's say that this ordered pair was, let's just say pi over 6. How long does it take you to get to here? How long does it take you to get back? Pi. From here, they're equidistant from one another. This does happen. Guys, they're going to make an announcement. I don't know.
Everyone's
Yeah, every other class is like
Fine, leave. And you add your pi in. And that's what it looks like. That's the difference between this.
Are we doing that next?
This school needs to be better communicating. I want you to do, these are the wrong ones. Do these. Yeah, through 24. There is one thing in here that's called a cofunction identity that you do not need to worry about. Sine of negative x is the same thing as saying this. Just putting the negative 1 in front of it. It just has a coefficient of negative 1 there. We'll worry about those identities later on next week. I want you to do those 6. Yeah. So it's 14.4, I think it's 7.
Wait, did this family homework?
Yeah. 8:59. There you go. Third round got it all done for a little. Not the riff-raffs out of here.
No.
They sent it a Twitter page?
Yeah, someone's like, we have the
They
picture.
showed me that, and I was dying. That's
It was
what,
creepy though. And
that's
someone
funny.
I'm so upset. I created him. Drew on him and gave him his name. Giuseppe? Ew, gross. Gilbert is such a better name.
The pie.
What?
Gilbert is better than
Giuseppe?
Giuseppe's one of the sweet.